Welcome to the session of Computer Assisted Part Programming, or otherwise known as APT, Automatically Programmed To. In the earlier sessions, we discussed about manual part programming, but these have got some disadvantages. That is, one is it is time consuming. If the complex job has to be done, then it is time consuming, tedious, and subjected to human errors for complex jobs. While the APT, the machining instructions are written in English-like statements. In manual part programming, we were used to some codes. That codes are actually used for writing the program. But here it is more English-like statements that we are used in APT. And these statements are then translated by the computer into low-level machine codes of the machine control unit. And APT is generally used for more complex jobs. In APT, the tasks are actually divided into two. That is, one is part programmer's job, and the second part is the computer's job. So the part programmer's job, that is in our interest. So that is actually one is define of part geometry. The operator has to give the information about the part geometry. Then the tool path, operation sequence, etc. should be given by the part programmer. And finally, other functions just like speed, feed, etc. also has to be mentioned by the part programmer. And the rest it will be done by the computer. In first, we will discuss how we will define the part geometry in APT. So the geometry elements are sometimes defined only for use in specifying toolpath. Okay, the example of part geometry definitions are this letter P is used for denoting points. So the points, all the points in a part has to be predefined by the operator. So here it is 4 stands for, it is a fourth point, the address is given as 4. So the point is actually defined like this, that will be explained in later. And capital L is used for line, representing line. L1 means this is the first line, like that. And capital C is used for representing a circle, and C1 means this is a circle 1. Next, the operator's job is to specify the tool path and the operation sequence. And in this case, we are using some commands like go to commands. Okay, go to P0 means the tool has to go to point number 0. Okay, that will be predefined the part geometry section. Then this go to is generally used for giving the point to point command, because from one point to other point. And the continuous path command, especially the continuous path, is used for having cutting operations in linear or circular path. So there we are using go left. This is actually stands for go left, and here it is tangent to. That is another command used for continuous path operations. Other functions which has to be done by the operator in a computer-assisted part programming is specified like this. That is the specifying cutting speed, feed, etc. So that has to be determined by the operator. Then designating cutter size, that is tool offset calculations. So cutter diameter, length, etc. The operator has to provide. Then specifying tolerance in circle interpolation, naming the program, identifying the machine tool. So these all are some other functions of the operator. Here we discuss the different types of statements used in APT language. This is very important. There are four basic types of statements are there in an APT. These are classified as, one is geometry statements. So geometry statements are actually defining the geometry of the elements. So the various geometries are the point, line, surface, etc. Then second one is the motion commands. So motion command is specifying the tool path. So based on the motion commands, the tool is moving from one point to other, or otherwise it is continuously moving along a direction. Then the third statements are coming under post-processor statement. Under this post-processor statement, the control, it is controlling the machine tool operation, that is the speeds, feeds, etc. Then set tolerance values for circular interpolation, and actuate other capabilities of the machine tool, etc. are done by these post-processor statements. Then finally we have got the fourth statement, that is the auxiliary statements. So auxiliary statements are actually the statements which are not involving directly in the machining operations, but these are required for some other purposes. So for example, name of the program, part program, is coming under auxiliary statements. So name is an identification symbol which is given to identify a particular program. Then insert command is another one, like that. Here onwards we are studying the different statements one by one. So first, the statement under consideration is a geometry statement. So geometry statement, it starts with the point. So this is an example of how to write a geometry statement. So first we will give the symbol and its number. So P1 is our point number 1. And point number 1 is first we will give what is that geometry type. So that we will give. So here the geometry type is point, P-O-I-N-T. And this point is known as the APT vocabulary, because so APT has got a number of words. So that is known as APT vocabulary words. So these are some kind of words which are used in APT. So here the first one is the point. Point is the first word in that vocabulary, and it consists of 6 or fewer characters. That is very, very important, because the character length is limited to maximum of 6. Here the point, we know that it contains 5 points, 5 characters, and the characters are almost always letters of the alphabet, capital letters we are using. Then in this structure, the second one is the descriptive data. Here for point, what we are using 3 coordinates or values. That is 20 means it corresponds to x-axis, 40 means 40 mm in y-axis, and 60 means 60 in z-axis. So three z values we are giving, otherwise known as minor words. So by this we can represent a point. So the designation of point can be done in 2 ways. First one already explained, using x, y, z coordinates, that is actually shown here. And in the second is it can be represented by an intersection of 2 intersecting lines. That means if we consider a line L1 like this, so L1 will be, if the L1 is predefined and L2 is also defined earlier, then L1 will be like this and L2 will be like this. If we know these 2 lines, then the intersection of this can be taken as 1 point. Okay. So that is another way of representing a point. So P2 is a point slash intersection of int of. In order to limit it within 6, it is shorted like this, int of, that is intersection of L1 and L2. That is another representation of a point. Next is a representation of another geometry, that is lines. So here the lines also can be represented in 2 ways. First one is a line is a connection between 2 points. Here it is P3 and P4. So the straight line which is joining these P3 and P4 is a line, and here this line is given as L1. So L1 is a line which is connecting P3 and P4. Otherwise, we can again define a line like this. This is a line P5 parallel L3. That means it's a point, it is a line passing through P5. That is one condition. Another one is that it should be parallel to another line, another predefined line L3. So P5 is like this and L3 is like this. So it should be go parallel to L3 like this. So this is our L2. This is another representation of line. And next is definition of a plane. So plane PL stands for plane. So the plane can be represented by giving 3 points through which it passes, provided this all the 3 points P1, P2, P3 must be non-collinear. It should not lie on the same line. So 3 points 1, 2, 3. So all the planes, all the plane which contains all the 3 points is actually the representation of this particular plane. Another representation of the plane, there's here the PL2. If we know the position or otherwise PL1 is already defined, then we can tell that this plane is passing through another point P2 here, and which is, and also this plane is parallel to the plane PL1. So it should contain P2 and it should be parallel to a plane known as PL1. So our PL2 should be like this. So it should be parallel to this PL1 and it should contain this point P2. So this now is this PL2. The last geometry is the center and radius, that is circle, circle. And the circle also can be defined in two ways. One is through center and radius. C1 is center 1, circle 1. So that is circle is written over here. We can see that it contains 6 characters. Okay, so that is the maximum number. And we have to mention what is the center. So the center is P1. So P1 is earlier, provided it is earlierly defined earlier. Then the radius we have to mention, that is 25 mm. So the center point is defined and the radius is there. By this we can have defined the circle. Another method of defining circle is that 3 points through which it passes. So here that is the example. So C2 is equal to circle P4, P5, P6. So P4, P5 and P6 are known. We can have the circle which is passing through all these points. Okay. So that is another style of defining the circle. The other 3 kinds of statements will be discussed in the next video. Thank you for watching.